as you come in, please take out your OTL number 7. Your teacher is going to hand you the answer sheet. There will be one for you and one for your partner. Please take some time to grade that, and when you're finished, give yourself 2 scores and pass it forward, just like always, except this time also please pass forward your answer sheet. Today we're talking about algebra properties. So today's the day that we get to start talking about proofs. But we've done that before. I mean, we've been doing proofs almost since January, actually even before that. So are you aware that you've been doing proofs for a very long time? Remember all those times that your algebra teacher was harping on you to show your work? Every time that you showed your work in an algebra problem when you solved for a variable, you showed the reader, you proved to the reader why your answer was correct. So this really isn't anything new. You guys have been doing this for a very long time, okay? All we're changing now, just a little bit, tweaking it just a little bit, is instead of just showing the math, okay, I added a number to both sides, I divided both sides by a number. Instead of doing that, we're going to actually be writing. So this is going to kind of shift a little bit from what we think is a math class to now what we think more of an English class might be. So you're going to have to do some writing, and we're going to do the writing using our green notes that you should have picked up when you came in. So you should have a brand new pack of green notes. They should say algebra, geometry, definitions, postulates, and theorems. This set of green notes has every theorem, every postulate, remember that means that it hasn't been proven, and every theorem that we have talked about and that we've explained why it's true. So this is kind of like money. You should treat it like a $100 bill. You shouldn't lose it because this is the thing that's going to have all of your reasons why you can say something. So just like in a persuasive essay, when we ask you, what do you believe? And give reasons to back up that idea. The things that are on your green notes are what back up your idea. Okay, so these are your reasons. So today we're mostly going to focus on the algebra side of it because that's the stuff that we're most comfortable with. So we've talked about, well, these things might seem new to us, but we all know that if I want to get x by itself, I'm going to have to move everything away from the x. And for each of those ideas, there's a reason that goes behind it. So we start off with what the properties for algebra are in our book. And this is exactly how they're stated in the book. So the reflexive property of equality means that A equals A. That's what our book says. We're going to decipher these. We're going to figure out what does that really mean in words a little bit later, okay? The symmetric property, that says that if A is equal to B, then B is equal to A. So some of us can see that the A and B have kind of switched their locations there. The next one is the transitive property. That one says that if A equals B and B equals C, then A has to equal C. And we've talked about that one in class. If I have 3 people that all have the same height, okay, and I know that, let's just say that I have Jack, Dave, and Tony, and they all have the same height, okay, I could say that Jack and Dave have the same height, Dave and Tony have the same height. Therefore, Jack and Tony have the same height. My first person and my last person must have the same height. So that's the same thing that we see here. The next one is the addition property of equality. That says that if A is equal to B, then A plus C would still be equal to B plus C. This is one that we use all the time when we solve for x because we add a number to both sides of the equal sign. That's how we get x by itself a lot of times. And then the last one in our book for equality was the multiplication property. And that one says that if A equals B, then we can take A times C, and that should still equal B times C. So that's where we can say, hey, we can multiply both sides by a number. So let's decipher it. The reflexive property. That was the one that said A equals A. So what is it that really means? All it's saying is that a number is equal to itself. Or in geometry, we might say that a segment is equal to itself. So we could say that AB is equal to AB. Well, when would that happen? Let me draw a picture. Let's see, maybe I have this green triangle. And then I have this red triangle that overlaps it, AB. Do we all see how we overlap AB right here? It's in both the red and the green triangle. That would be in a time when we would use the reflexive property to show that it's equal to itself. So it seems like a silly one to say, but we actually really do need it in a lot of different instances in our proofs. The next one was the symmetric property, and that one said that if A was equal to B, then B was equal to A. It just said that we can flip-flop, switch around what's on what side of the equation, as long as we take both sides, everything on both sides, and switch them. Some of us really like to have the x left on the left side when we solve an equation. Some of us really like to have the x left on the right side when we solve an equation. This is what allows us to switch those things around. The last one is the transitive property of equality, and that was the one where we can compare three people's heights. We could say person 1, person 2 have the same height, person 2 and person 3 have the same height, so person 1 and person 3 must have the same height. Okay, same idea here. Okay, it just allows you to conclude that if two measures are each equal to a third measure, okay, then the first two must be equal. So if the first and the second are equal, the second and the third are equal, then the first and the last have to be equal. That one is very, very, very intuitive, meaning most of us could probably explain that without knowing what the transitive property is, without knowing the specific name for it. Going to the addition property and the multiplication property for equality, remember that one just said that if A equaled B, then A plus C equaled B plus C. It just said that you can add or subtract the same amount from each side of an equation. And the reason that we don't want to that we say add or subtract is because we can think about adding as adding a positive number or adding a negative number. Some of you guys like to write that down a lot, plus a negative, okay? And that would just be the same thing as subtracting. So in this case, we only give it one name, adding, because adding and subtracting go together. Then we have the multiplication property of equality. That one said in the book, if A was equal to B, then A times C equaled B times C. So same idea. You're just multiplying both sides of the equation by a number, by the same number. Again, we could multiply or we could divide. Because remember, we can always make a number look like a fraction that we're multiplying by. So if we really meant to divide, if we wanted to do 3x equals 12 and we wanted to divide by 3 to get x equals 4, it would also be correct to think about it like this. We could also think about it as multiplying by 1 over 3 on both sides. Think about everything as a fraction. Our 3's would cancel, leaving us with x. And over here we get 12 over 3, which is 4. So really it's the same exact idea, is the adding and subtracting. Multiplying and dividing, they go hand in hand together. So right now we have 5 different properties that we have talked about, and now we're actually going to practice using them. So here's a pretty standard problem that I could have given you to solve. It says solve for x. That's what they did on the left-hand side over here. They solved for x. Okay. What we're going to do on the right-hand side is we're going to give a reason why they could do whatever it is that they did. So sometimes we're going to have to look to see what is it that they did first. That's kind of the first step. Once we know what it is that they did, then we can come up with the reason why they could do that. So as I'm looking, I always start my first statement, that equation that I'm starting with, we always say is the given. Okay, so we always say that that starting thing is given to us. We can't make it up on our own. So how did I get from here to here? What did they do? Well, it looks like they added 8 to both sides. So that would give us 50x equals 128. What property is it that says that we can add a number to both sides? That would be the addition property, and if you want to abbreviate property, that's fine, of equality. And it's going to be important that you write out the entire thing because we are also going to talk about what happens if we have an inequality. So if we have one of those less than or greater than signs. Okay, so we want to include that equality piece over here. So now as we look to get to the next step, what looks like it happened? Well, it doesn't look like any numbers changed necessarily, but it does kind of look like the 50 went to this side of the equal sign and the 128 went to the other side. So it kind of looks like they crossed or they flipped which side of the equal sign they're on. If you're looking at your 5 properties, which thing says that we can flip sides? As you look, hopefully you're looking and you're going to say that it would be the symmetric property. All right, so we've got our first 2 steps done. We've explained why they could do those steps. We're going to finish her off here. So the last one, or the next step, how did they get from here to here? What did they do? Well, it looks like the x is by itself now, so it looks like they probably divided by 50. What property says that we can divide both sides by a number? And this is kind of the tricky one. Hopefully you're thinking dividing and multiplying go together, so it's going to be the multiplication. Property of equality. Again, we're going to want to make sure that we include the equality part on there because we're going to talk about what happens when we multiply with an inequality. And then what did they do to get from that step to the very last step? Well, it looks like they just punched it into their calculator. We didn't really give a reason for that. There is no reason to punch something into a calculator, so I think we should just call it, let's just call it simplifying. Because I think we can all argue that we could just simplify what that fraction is, or we're just writing it a different way. All right? So there, we did our first proof, our first algebra proof. Wasn't so bad. Let's try another one that's going to be very, very similar. It says justify again each step using our equality postulate. So we're starting out with what we are given. We're going to have to figure out what they did each step of the way and then give a reason why they could do that. So as we look from our first step, from our first equation to our second, it kind of looks like as we're browsing, nothing really looks like it changed. So maybe now we're checking out to see, did things switch sides? Looks like the 84 went to the other side, went to the left side of the equal sign, and the 24x plus 12, that whole thing went to the right side of the equal sign. So if we're looking at our 5 properties again, which one says that we can switch sides of the equal sign? And hopefully you're thinking that's the symmetric property. And a lot of people get symmetric property and reflexive property mixed up. So I always remember symmetric, it's kind of like in a mirror. When you look in the mirror, you're symmetric with what you see with your reflection. The only thing is you're always reversed in the mirror. Okay, so that's how I always remember it, is that it looks like I just reversed what's on each side of the equal sign. So that would be a good way to remember that it's symmetric instead of reflexive. As we look, come back to our problem here, how do we get to the next step? What happened? On this one, oh boy, it kind of looks like they switched again. It looks like the 24x went over there, and they also subtracted 12. So, oh man, they did 2 steps at once. I know that you guys do more than 1 step at a time. So we're going to have to justify each step. Because when we subtract 12, we get 72 over here, and now it's back on the other side. So I'm going to say that the first thing that they did was they subtracted 12. What allows us to subtract 12 from both sides of the equation? Remember, adding and subtracting, they go together, so that would be the addition property of equality. Then they switch sides again. So that would be the symmetric property again. Okay. Oh, 2 steps there. But it wasn't hard. It was okay. You just had to pay attention. Now you know what the teachers go through when they try and grade your paper and figure out what you did. So the next one here, to get to the next step, it looks like they divided both sides by 24 because x is by itself now. So what allows us to divide by 24? What goes with dividing? I don't have a dividing one on my paper, but I remember that multiplying and dividing go together. So it must be the multiplication property of equality. And then finally, it looks like they just punched it into their calculator to simplify it. Two done. Not so bad, not so bad. So we're pretty good with the equality stuff. Those aren't too bad. I think I could give anybody some algebra problems now and say, find x on one side and then justify each step on the right side. Everybody should be able to do that now. The next thing that we have to talk about is what happens if we have an inequality. So if the equal sign is replaced by the inequality sign, we're replacing the equals now with a greater than or a less than sign, would each of these postulates still be true? Well, with equality, it said 3 was equal to 3. So if we take the equal sign and we replace it with the inequality sign, would that be true? Is 3 less than 3? I would say no. So this one does not work for an inequality. We don't have it for an inequality. It only works if we have an equal sign. If we take a look at the next one, the symmetric property, that one said that I could flip-flop what was on each side. So I could take x and y and I could flip-flop them. Would that work if I changed the equal signs to inequalities? Okay. Would it work? Well, let's pick some numbers for x and y. Would it be true 2 is less than 5? So would it be true then that 5 is less than 2? Because we just take those two numbers and we flip-flop their places. And as I'm looking at this, this is not true. So therefore, the symmetric property does not work if we have an inequality sign. It only works for equals. Only works for an equal. The next one is the transitive property. That one said that, if we had our three things and they were equal to each other, then the first and the last would be equal to each other. Okay, what happens if we replace all of those things with inequalities now? So I'm going to pick some numbers again to fill in. Let's say that AB is 3 and CD is 5. 3 is less than 5 and CD was 5. Let's make EF 9. So 3 is less than 5 and 5 is less than 9. Those are both true. Would it be true that then AB was 3? Would it be true that 3 is less than 9? Would that work? Is 3 less than 9? Absolutely. So that means that the inequality, the transitive property works if it's an inequality or an equality. So if it's an equation with an equal sign or if it has an inequality. So there are actually 3 of them that work for inequalities, and then there are 2 others that are real quick. We have the transitive property of inequality that just says that, if A is less than B and B is less than C, then A has to be the smallest thing out of all 3 of them. The addition property of equality, that one says that kind of the same thing as the equality one, but now we're talking about an inequality. So if A is smaller than B, then I can add a number to both sides, and A plus C will still be smaller than B plus C. Here would be an example. If A equaled 2 and B equaled 5, and C was going to be 3, okay, when I do 2 plus 3, that has to be less than 5 plus 3. 5 is in fact less than 8. Okay, so it's just saying that even if you add a number to both sides, it's still going to keep your inequality facing in the same direction. And then we have the next one, the multiplication property of an inequality. And that one is very similar to the multiplication one with a little tiny glitch. Because we know that something happens when we multiply or divide by a negative number if we have an inequality. So the first part, if I just multiply by some number and it's positive, okay, it has to be positive, then nothing changes. It's all good. Nothing changes. The inequality sign stays facing the same way. However, if I multiply by a number that is smaller than 0, So like a negative number, that's going to change my inequality, okay? So that's going to make my inequality flip signs. So it flips when you multiply or divide by a negative number. And we have talked about that because we spent some time at the very beginning of the year working with inequalities. And hopefully everybody still remembers if you multiply or divide by a negative, that sign has to flip. So here's an example. If the measure of angle P is smaller than the measure of angle Q, and the measure of angle Q is smaller than the measure of angle R, hopefully, okay, so this one, P is the smallest. We can say that P is less than R because P was smaller than Q and Q was smaller than R. Well, that's, again, if you're thinking about which reason it might be, we're comparing three things. We're comparing their sizes. When we compare three things, like when we compare three people's heights, okay, Dan is taller than Jim. Jim is taller than Tony. Okay, therefore Tony has to be taller than the first person that we talked about. Okay, that would be the transitive property. But this time it's the transitive property of inequality. And we have to write out that entire thing. Because we compared three things. The bottom example here says in the figure at the right, this gets kind of confusing because there's a lot of letters here, so I think I might add some numbers. The measure of angle DBC was X. I'm going to call that angle 1. Okay? And the measure of angle HEF was Y. So HEF, we're going to call that angle 2. And the measure of angle ABD was equal to the measure of angle GEH. So let's go ahead and fill in. Let's see, let's call this angle 3 and angle 4. So those two angles are equal. Angle 3 and angle 4 are equal. We're going to call them Z. There's just too many letters in here, and we've talked about how if there's a lot of letters and it gets kind of confusing, you can always number those angles to make it easier for yourself. So what we have right now is that we have an angle 1 and an angle 2, and then we have an angle 3 and 4 that are going to be equal. So we know that angle 1 was smaller than angle 2. And I'm going to do that in red because it's kind of hard to see. Angle 1 is smaller than angle 2. So what would allow us to say that angle 1 plus angle 3 would be less than angle 2 plus angle 3? Well, what are you doing there? What did you do to both sides of the inequality? Hopefully you're saying we added an angle that's the same on both sides. And since it's adding, that's a pretty easy one. It's got to be the addition property. Since it was an inequality this time, we're going to call it the addition property of inequality because it was a less than sign. Here are two more. We can try this again. It says we have the measure of angle T bigger than Q, And now it looks like we're going to multiply both of those angles by a number that's bigger than 1. What allows us to do that? To multiply a number on both sides of that inequality. Well, that's an easy one. We're multiplying. Must be the multiplication property of inequality this time, because it was a greater than sign. So sometimes it's identifying what happened. Okay, well, what happened from what we started with to what we ended with? Well, it looks like they multiplied both sides by something. Multiplication. Half the battle is won, and then you have to decide, was there an equal sign or an inequality sign? And then you're done. We have another one here. It says, using the figure at the right, we know that the measure of angle 1 is greater than the measure of angle 3. And the measure of angle 3 is greater than the measure of angle 6. What allows you to conclude that the measure of angle 1 should be greater than, that should be a greater than sign, so please change it. What allows you to conclude that the measure of angle 1 is greater than the measure of angle 6? Again, we're comparing three things. We're comparing three things. That's going to be your transitive property. So hopefully up until now, everything has seemed pretty logical. Okay, you've learned, you've spent time talking about how you can add something to both sides or subtract something from both sides, multiply by something on both sides, whether it's an equation or an inequality. So I guess as I look at this is all pretty new to us, but the ones that are new that we're not comfortable with, the words, are probably transitive, and the next two that we're going to talk about. And the next two are kind of neat because they allow us to do two pretty cool things. So the first one is the equation to an inequality property. This one says that if I know that two things are equal, okay, if I know that something is equal, then the total has to be bigger than the two parts when they're by themselves. Okay, so it basically says, this is the way that the book writes it, if A and B are positive and A plus B equals C, so we're taking two things, we're putting them together to get the total, then the total has to be bigger than A and the total has to be bigger than B. So the total has to be greater than the two things when they're not combined. And the key thing here is that they both have to be positive numbers. So informally, we could write the whole is greater than its parts. Where this becomes useful is when we start talking about different examples where we want to take some pieces, something that's a whole, and break it up into smaller pieces and then compare their sizes. So we're going to see some examples like that. The other one, this is the one that you guys have been using. We've used this before in class, is the substitution property. It just says that we can pluck a letter out, we can pluck something out and replace it with something that it's equal to. So if A and B are equal, then A may be substituted or replaced for B anywhere. We did this a while ago, a couple of units back, so this shouldn't be new. Okay, especially when we give you an example like this. If x equals 2, find 3x plus 6. This is the most basic type of substitution. You're going to take the 2, you're going to put it in for the x, and add 6 to it. 3 times 2 is 6, plus 6 more is 12. That's substitution. Okay, you're taking something out, you're replacing it with something that it's equal to. Just like in basketball, we don't want to take out our star player and replace them with our worst player. We want to make an even trade, star player for star player. We don't want to take out our quarterback and put in a running back if we don't have to. Okay, we want to trade quarterback for quarterback. So here are some examples. It says, what allows you to conclude that if 2x plus y equals 18 and x equals 4, then 2 times 4 plus y would equal 18? Well, what looks like it happened? X is gone here, down here, and it looks like the 4 went in place of the x. I think we call that substitution. That one should be the easy one. Now we're going to take a look at one that says something a little different. Using the picture at the right, what allows you to conclude that if xy plus yz, so I'm going to take these two pieces of my segment, okay, I'm going to break them up into two smaller pieces. What allows us to conclude that the red one is smaller than the green one, and the green one is, or the blue one is smaller than the green one. So again, we're taking a whole thing, we're breaking it up and saying its pieces are less than the total when they're put together. That one is the equation to inequality. I think I'm going to have you try the next two on your own and check your answers once you're finished. So we'll give you a few minutes to do those, and then we'll check your answers when you're finished. Read carefully. All right, so you should have those two done. The first one was an equation to an inequality. So they started out with an equal sign, adding two things together to get the total. And then our concluding statement would be that then the total is bigger than the part, and the total is bigger than the other part. That's our equation to inequality. The bottom one was substitution. That one says that we're just going to take the 4x plus 1 and we're going to slap it in wherever we see a y, because that's what it was equal to, was y. So remember, we see a y by itself. Wherever we see a y, we can take it out, and we can replace it with 4x plus 1. So that one's substitution. So what we would like you to do for the remaining time is you can have a practice sheet. It's one page front and back. It should be attached to your notes. You are going to finish that sheet working with your partner using your notes from today. By the way, your green notes, where are all these things that we talked about? The green note packet that you picked up today, all of the things that we just talked about are on the front of the second page, on the front of page 2. Okay? So they're all there. They're at the bottom half of the page: reflexive, symmetric, transitive, addition property, multiplication property, transitive property, equation to inequality, and substitution. They're all on that the front page of the second sheet of the new green notes that you just picked up. So it says you're going to complete the practice problems that are the remaining problems. You're going to put your name and your partner's name on them. You're going to complete them. You're going to check your answers. They are on the front board. When you're done, you can start the homework. Homework is pretty short for tonight. All right? And we'll see you guys on Monday or Tuesday.